We are one of the groups working on the Farmyard Enrichment Project, and the two bulls at the Durham Museum of Life and Science, Dusty and Dallas, are in need of a new feeding device that will help simulate their natural foraging behavior. Our design solution achieves these goals by lengthening feeding time and increasing physical activity before, during, and after feeding.
So our main motivation for this project is focused on behavioral enrichment because animals in captivity often don't have the same opportunity for exploration and food acquisition that animals in nature have, and it's been shown that the well-being of the animals is greater when they have this physical and physiological stimulation.
Currently, the feeding method involves the animal care specialist placing hay in troughs, which takes the bulls around 15 minutes to eat, and then they just sit around the rest of the day. This method of feeding lacks both physical and mental stimulation.
In order to come up with an adequate design solution, we consulted our client to come up with a list of design criteria. The first, that was a constraint, was that our device needs to be enriching for animals, and to determine if our device succeeds in this regard, we determined that it should take the bulls greater than 15 minutes to consume their food, and also make sure that they're covering at least 50% of their yard during the feeding process. Next, we had safety. The hay must fall greater than 12 inches away from the feeder, so the bulls don't hit their head on it when they feed. It should also be efficient and take the animal care specialists less than 10 minutes to operate. It should hold enough food for the entire day, which is at least 12 flakes of hay. It should be durable and withstand outside weather conditions for up to at least a year. And it should also cost less than $100.
Our design essentially works like this. So first, the bull will be walking around, and near one of the fences there will be a motion sensor. The bull will walk past the motion sensor, which will activate the motion sensor, and then this will activate a feeder box on the other side to open a latch, and hay will drop down. And essentially the bull will then have to walk over to the other side of the yard to eat the hay, and the bulls will try to walk around more to activate more motion sensors, and this will increase their feeding time as well as increase their motion throughout the day.
Our current prototype is made of 1/8 inch plywood and is 10 by 18 by 22 inches and has a manually operated top door and a door on the bottom where the hay falls out that is controlled by a latch.
For the electrical component, we're planning to use Bluetooth, but there is a lot of issue with troubleshooting, so we decided to just directly connect the motion sensor to the servo motor for this current prototype. And essentially the motion sensor will activate the servo motor, which will then open a latch, and then that will allow the hay to drop through.
In regards to testing, we decided that since this is not our final product that we would ideally hand over to our clients at the farm, we broke down our testing into components and categories, and we tested each individual component separately.
So we tested 4 different components. We tested that the Bluetooth transceivers communicated. This was before we took that part out of our current prototype. They did communicate well, so that test passed. The motion sensors send the correct serial. That test also passed. And the servo successfully opened the latch multiple times, as you can see in the video, so that also passed. Since our current prototype, which is 1 compartment, holds 2 flakes of hay, that means that our entire final design, which includes 6 compartments, would hold greater than or equal to 12 flakes of hay, so that test passed as well.
So our current design is 1 compartment that's to scale and functioning, but ideally we want to make 6 of these compartments.
In addition to scaling up our design, we also want to make it out of more durable material that would actually be used at the farm, and also include the Bluetooth and multiple servos. Having a higher fidelity prototype would also allow us to continue to conduct more quantitative testing that align with the rest of our design criteria to determine if our prototype fulfills the original goal. So overall, we have designed a prototype and design solution that will enhance the enrichment of the animals at the Durham Museum of Life and Science.